Hello, this is Mr. B with another episode of Math in the Classroom. We are going to go through our sine, cosine, tangent today, and then we'll go from there. Since we have to use the calculator for this one, we'll use the overhead, so you won't see me, but hopefully you'll be able to hear me through instruction. All right, here we go. So for our learning target today, we are going to do I will be able to use sine, cosine, and tangent to solve for a missing part of a right triangle. Okay, as far as the learning target goes, there is a lot there that is there. We have to have certain qualifiers to make sine, cosine, tangent work. One of the things that you notice is that it has to be to a right triangle. And then as far as today goes, we are going to work on solving for just the leg or the hypotenuse. Later on, we'll be able to use sine, cosine, and tangent to solve for the missing angle. But for right now, this is what we're going to be starting with. So, like I said, this is to help us solve for a missing part of a right triangle. Right triangle means that we have to have at least one 90-degree angle in the triangle, or we have a 90-degree angle in the triangle. So, to understand, before we get going, what the different parts are, we will kind of start off with the trig acronym that we use for sine, cosine, tangent. Then we'll explain how the different parts of the triangle work, and then we'll show you an example for one of the sine, cosine, or two examples for sine, cosine, tangent, something like that. So the first thing we got to know is this one, so, ka, toa. Sounds kind of like a chant to me, soka toa, soka toa. It's one of the ones that has been used forever, and it's because it works, it's because it helps, and I like to find those nice little tricks to be able to remember things. So here we go. What does that stand for? Well, so stands for sine of theta is going to equal opposite over our hypotenuse. Again, I know those are abbreviations, but we'll talk about that a little bit more. Cosine of theta is going to equal adjacent over hypotenuse, and tangent of theta is going to equal opposite over adjacent. Now notice it goes in order, top to bottom, top to bottom, top to bottom. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay? And again, theta, that's our Greek letter, theta, and a lot of times we use those Greek letters when we're representing angles of triangles. All right, what does the opposite and adjacent and hypotenuse, how do we determine what those are? It is based off of what the reference angle is. So if we change our reference angle, we're going to change where our opposite and adjacent and hypotenuse is, kind of. Hypotenuse doesn't change. Hypotenuse is always opposite of the 90 degree. Okay, there it is. So if I say this is my theta, this is my reference angle, the way that I explain it is kind of like this. If this was a cannonball, if it was shooting out of that angle, it's going to hit the side that is opposite, and you know that because the O for the theta, they kind of correspond. Boom, there it is. Okay, process of elimination then, this is going to be our adjacent. So again, opposite, adjacent, and hypotenuse. Okay, those are abbreviations that we're talking about. Now, if we had something a little bit different, say this is now our reference angle. If we were to shoot the cannonball out, this would now hit opposite. Opposite of our 90 would be our hypotenuse. And process of elimination, there is our adjacent. Okay? So we have to be able to identify those parts before we can figure out what our sine, cosine, tangent is for different stuff. Okay, we'll give you a little chance. If you need to pause the video now. We're going to go to another clean piece of paper for the next part of the notes. Okay, so now if we were looking at a right triangle, something like that, and let's say this angle here is going to be 28 degrees. Let's say this is our x, and let's say our hypotenuse is 11. Okay, we want to solve for our x. Now, a couple things that we keep in mind. This is the angle that's given, so that is our reference angle. So from this angle, I like to label what this is. Given this reference angle, this is going to be our opposite, and this is going to be our hypotenuse. So thinking about our TOA, which one uses opposite and hypotenuse? Hopefully you say sine. So we'll set it up like this. Sine of 28 degrees is going to equal our opposite, x, over our hypotenuse, 11. Once we're here, then we just use a little bit of algebra. To get the x by itself, we're dividing by 11. So the opposite of dividing by 11 is going to be multiplying by 11. What we do to one side, we do to the other. So we're going to get x equals 11 times the sine of 28 degrees. We grab our calculator. It's going to be a little hard to see, but we'll kind of do our best with this. First thing we're going to do is we're going to check to make sure that it's in degree mode. So we click on mode. We scroll down and notice the degree is highlighted, so we can hit second quit. And we are in degree mode. And type it in just like we have it. 11 times sine of 28 degrees. Close our parentheses. And there it is. So now our x is going to be approximately 5.16. Now, a couple things that I'm really careful about when I'm teaching my students. Here, this is an equal sign because this is the exact value. Here, this is the approximately sign. So that's that wavy equal sign because we have rounded. When I teach this, one of the things that I show people and show students is this is essentially built off of our Pythagorean theorem. You can kind of think of that a little bit in the sense that we have the a squared plus b squared equals c squared. Now, even if we do a simple 1-by-1 triangle, when we solve this, we get 1 plus 1 equals c squared, 1 plus 1 equals 2, equals c squared, square root of 2, so our c would equal the square root of 2. Now, if you know too much about simplifying radicals or taking the square root of 2, this is what's called an irrational number. What is the irrational number? That's that decimal that goes on and on and on forever but doesn't repeat, something kind of like pi. So when we're solving for these different lengths, a lot of times we end up with irrational numbers. Not all the time. but a lot of the times we do, so we have to say that we have rounded. If we have a perfect case like a 3, 4, 5 triangle or multiple of, when we solve it down, we'll get the exact answer. And if we have the exact answer, then we will still use the x equals whatever that answer is, but kind of keep that in mind. All right, that's Mr. Bissonette with another episode. Thank you for watching. Like, subscribe. If you have a question, feel free to put that in the comments below. Thank you.